The aim of the project is to see how clean the water on campus is, and compare the qualities of water found in different places on campus. We'll do this first by constructing an apparatus which can attach to a phone which has a camera. This is our design for the 3D printed phone attachment. To compare water from different locations on campus, we collect samples from the physics building, being very near the heart of campus, and also take samples from North Campus at Peabody Hall, West Campus at Brumby Hall, South Campus at Dr. Zhao's Research Laboratory, and East Campus at Joe Frank Harris Commons. We clean glass bottles to take the large samples of water, then pour a small amount of each sample into the respective vial through which we shine light. Light enters the tube of the 3D printed apparatus and travels into the camera of the phone, but before it does so, it passes through a 500 nanometer diffraction grating. The slits in the grating cause the light to bend, and since each wavelength of light does this slightly differently, the wavelengths of the light separate, and we observe this separation as having different colors than the original white light. These colors are observed through the camera of the phone as spectral lines, such as this, which is an actual picture from our experiment. The lines arrange themselves in certain ways according to the material through which the light passes before entering the diffraction grating and camera, so if one observes the spectral lines from a substance, they can reasonably know the contents of that substance, in our case, water. Here's a real-time video of what one can see by using the phone with the apparatus. The spectral lines are very clear and constant, so we would find the spectral lines, take pictures of them with the camera, then use a program to evaluate the materials in the water via the appearance of the spectral lines.
Currently, what we are doing is filling our vials up with the samples. We have two samples from the physics building.
Our state-of-the-art research lab.
Oh yeah.
We're out in the field, tearing it up.
Ton of funding.
A sample from North Campus that was taken in the
Peabody Hall.
Yeah. Sample from West Campus taken in Brumby Hall.
From Brumby Hall, West Campus.
Oh, the exciting times for science.
Oh yeah, I'm super excited, honestly.
Sample from South Campus taken in Dr. Zhao's lab building, the South Research Building. And an east side from Ramsey area. Specifically from...
ECB itself.
Yeah, ECB, the lower floor.
Joe Frank Harris Commons.
Yeah.
Ooh.
So let's do this. We're going to be grabbing the vials, of course, with cloth to prevent getting too much or any oils on them. Then we're going to go through with our tests on the phone. Hopefully the spectrometer will shape up. Who knows? All right. And our spectrometer that we've 3D printed is fairly straightforward. It's a body that you can press against your cell phone. Your camera should be around here. We have a cylinder tunnel, going down, ending at an angle here, where we have a diffusion grating paper over that hole. We will shine light through our vials that will then be broken up. The resulting spectrum that comes through the water will be broken up, and we will analyze that data to see what we can find in the water in significant portion.
Here, we're setting up the light to pass through each vial with water from each place around campus, then taking the pictures of the spectral lines. We used a program to analyze the pictures and compare them to a sample that allowed for the least absorbance, which is to say the sample with the best water quality, or the reference sample. The number on the right here represents the correlation between its light intensity versus wavelength distribution and the distribution of the same value for the reference sample, such that the greater valued number corresponds to a better water quality. As you can see, contrary to what we thought, the water from East Campus, which looked kind of murky at first, was actually the cleanest out of all of the samples from around campus. Here's the distribution of the sample from Brumby Hall compared to the reference sample, and it's clear to see that the sample from Brumby has different contents from the reference sample, and we thought at first that the further that the water from a treatment plant goes via pipes, the more contents it will contain when it comes out of a water fountain, unless there's some filter in each water fountain, in which case the water quality would be totally dependent on the filter in that fountain, as well as other factors like whether it was installed correctly, the degradation level of the small piping that exists in between the filter and the end of the fountain nozzle. But using just a few materials and a phone with a camera of at least some quality, one can see that the water that they probably drink every day and trust actually contains some materials that they didn't think were present. And that was definitely accomplished with this experiment.